you, everybody who is watching this fantastic lecture? My name is Olenjolaim TAYAI from the beautiful, fantastic country that's called Tanzania. I'm very happy to welcome you into this fantastic lecture of Lecture 2 that is titled as Functions of the Several Variables. And before even I go into too much details of these sessions, I would like to welcome you into our online institution that's called the Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim. And because I'm teaching you mathematics simultaneously, we have simultaneous programs solving 3 unknown simultaneous equations of 4 unknowns or 5 unknowns. We can solve this by using the power of the matrix and even MATLAB. So simultaneously, I would like to welcome you into our one of our YouTube channels that's called the Online Undergraduate Polyinstitute of Tanzania, in square bracket Olenjolaim. So before I take you into this lecture 2 of functions of several variables, I would like just to give you a few announcements which are very important to allocate you in a proper location so that you can navigate and you can enjoy the beauty of these institutions, online institutions. Well, so first of all, you know that what the word of God that's used to say that if there is no vision, people perish. That is Proverbs 29 verse 18. It means if I don't have visions and my students don't have visions, we are going to perish, all of us. And I'm not ready to perish, and I know even yourself that also you're not ready to perish. So this is the vision we have in these online institutions. Have been given an assignment by God himself to train, to teach, first of all to teach, to train, to incubate, to mentor, and even to lead some group of students who are in undergraduate level in engineering and scientific courses. To teach them means that I have a responsibility to teach them who will be ready to take the classroom instructions in engineering mathematics as a fundamental course or module, combining with the core, with all the informations extracted or which will be extracted from the core modules or from the course, right? And hence combining with the knowledge of Word of God, that also that I'm going to teach you in the another departments that called departments of the kingdoms of heavens, or sometimes that you can call it departments of the spiritual education. Okay, so that's the vision of this platform in order to solve real life problems. So in short, the vision we have in these online institutions is to train, to teach, to incubate, to mentor, and to lead some group of students who are ready to take the classroom instructions that are found in the formal and informal education, combining with the knowledge of Word of God in order to solve real life problems, regardless of the size of these real life problems, whether they are small scale, because there are small scale real life problems, medium scale real life problems, and even large scale real life problems, and there is extraordinary large scale real life problems. So our main objective in Online Undergraduate Polytechnic Institute of Tanzania is not to teach students in order to have certificates or just to graduate. Our main objective is to see our continuing students and even graduate students, they are really solving real life problems. That's our main objective. We have also some few specific objectives, a lot of specific objectives in the platform. And some of them we want to, first of all, to make all our students to love engineering and scientific mathematics, high engineering and scientific mathematics. Secondly, we like also to help our students to go through the continuous assessment is successful with actual a good pass mark and good performance in those in that category. But thirdly, we like also to teach our students to think differently and to see that how engineering mathematics can help them to solve real life problems. So we have so many specific objectives that we are going to build in our mind as long as we continue. So well, in Online Undergraduate Polytechnic Institute of Technology of Tanzania, we have a department. One of our departments is called the Higher Engineering and Scientific Mathematics. And with these departments, we are doing great things because we are actually trying our level best to meet the demands. And the demands is undergraduate students. And our area of focus is we are using the syllabus and curriculums of United Republic of Tanzania specifically. However, that this contents the undergraduate engineering and scientific mathematics is universal. So even what the contents that I'm going to teach you, that they're helpful, they can help students in China, in any continents, in Asia, in Africa, and South Africa, in Guinea, in Nigeria. So you can use these contents in order to help you to understand the concept, because actually that we are going to do extraordinary things in this platform. So because I say that we are going to have a focus of the curriculums of United Republic of Tanzania, we have two educational systems that usually I used to repeat several times, TCU and NACTE. And in these departments that I'm going to teach you 12 modules or 12 fundamental courses in engineering and scientific mathematics. So, well, you're warmly welcome. Now, I have a lot of things that to tell you, but stay connected and stay tuned, then you'll enjoy a lot of things. But against another thing that I will be using to, as I said, because I want to do this quick review so that you can be well positioned. So the course of the day or the modules is called several variable calculus. This is universal module, worldwide. But these modules are we using the syllabus of University of Dar es Salaam, as I said. However, that don't be confused because of the institution or the university that we are providing these modules or this course. Don't worry about that ones. Just to be peaceful. Know the course. Have the course outlines of your course. And once you have the course outlines of your course, you'll find, because for me, I used to give the all introductions, the general introductions of every subject or modules that I'm teaching you, so that you will notice what are the topics that you can learn from these modules or from this course. So stay connected and enjoy the beauty of engineering and scientific mathematics. So the chapter is chapter 1. We have some chapters. As I mentioned, you have 5 chapters in this course. And then the topic, the chapter is called the function of several variables. We are in lecture 2. So we are done with lecture 00, which is general introductions of several variable calculus. And also we are done with lecture 1, which is general introductions of function of several variables. And one of the topic that we have been discussing a lot of things. So this is the course at University of Dar es Salaam offered to the in first semester of second year in College of Engineering and Technology, COET. It's called the COET in short. Again, if you feel from your heart that you want to offer God your free willing thanksgiving in order to make sure that these so many lectures of several variable calculus should be in air so you can access them at any time, and even that you are anywhere else in the world, you can offer your free willing thanksgiving. So this telephone number so that you can be participating and supporting the running cost for this program. Really, it's expensive to run these programs. That's why that even other people, they're not doing, because of one of the factor is expensive, right? But our God is great. When you watch the lecture 00, which is titled as General Introductions of Several Variable Calculus. So you watch this, these sessions of this video, you'll learn a lot of information that I insist you to make sure that you go through, because it's in our YouTube channel, so that you can learn a lot, because this is the beginning of. So let me do the quick review of lecture 1. In lecture 1, it has been titled as General Introductions of Functions of Several Variables. These are the initials of the words, right? So General Introductions of Functions of Several Variables. So it is in this lecture, actually, that first of all, I've shared with you about the big picture of 40 of mathematics, and show you where do you get these modules of several variable calculus. Because several variable calculus is the one of the branch of 40 of calculus. So mainly in calculus we have two types of the, it deals with two types of the, or you have single variable calculus, and also you have several variable calculus. This single variable calculus, this is several more than one variable calculus. But remember that, as I say, that this is the contents for the TCU and even some students who are doing NATE, okay, who are in NATE, for those who are studying Tanzania. But if you are actually not in NATE students of University of Dar es Salaam, so you have to make sure that you extract the information which are very important or useful for your fundamental course. And then afterwards, I've presented to you the specific objectives, or the general objectives, right? The general objectives that will be focusing on them, and 5 general objectives. But also, I have presented to you about the topics, the 5 topics of 40 of several variable calculus, right? And then also after that you present these general objectives and specific objectives of this of the several variable calculus. Then I presented to you about the topics, or the subtopics, or the concepts. This we call them concepts. Concepts of what? Concepts of several variable, or function of several variable, function of several variable. So today we are going to begin with the first concept that you are learning. And these concepts I'm going to teach about function of several variables. Say function of several variables. Again, say functions of several variables. And remember that in lecture 1 I left my homework. And the homework is what is the meaning of function of several variables. So I'm going to answer that questions, but not now, later on. So he said that, let me begin with the big picture. He said that classes of what? Of functions in mathematics and also even in what? In engineering. So we say that there are two types, or there are two classes, right? The class of functions. There are two classes of what? Of functions. There are two classes of functions in what? In mathematics. Okay? Or let's say that yes, in mathematics. Let us say that. Okay? These two functions, these are the first class, we call it single variable function, or function of single variable. So let me just mention function. So this is what we've been learning from primary education. Function of single variable, function of single variable, yes, functions of single variable, right? Functions of single variables, singular. And hence, the second class, we have function of, or functions of what? Of several variable, right? Several variables. So these are the two classes that we have in mathematics. And because we need some concepts as tools, because mathematics is the engineering tools, as I used to call, and that is how we used to call, that mathematics is the queen of engineering. So because it's the queen of engineering, and we need this mathematics as the tool of learning engineering core courses and even scientific core courses, so then we say that with these concepts of function of several variables means that we have two classes, even in engineering mathematics or scientific mathematics. Functions of single variable, say it, and functions of several variables. So the good news, this is the good news that from primary education or from primary mathematics to basic mathematics or additional mathematics in ordinary level, to advanced mathematics in advanced level, or we call it to the basic engineering and scientific mathematics in ordinary diploma. And even maybe that in a first semester of calculus that you've been learning about the calculus and the etc. calculus, you've been dealing with only with functions of single variable. So that's why that we have to teach you another new functions or another new class in mathematics, which will make you to be a very powerful mathematicians, and even that you won't be limited, because some of the real life problems we can describe them by using functions of several variables rather than functions of the single variables. And that's the truth, because we find that maybe one parameter depends on more than two parameters. So this parameter which depends on those independent parameter, we call it dependent variable, and those parameters which are being dependent by the other parameter, we call them independent parameters. And I will give you some real life examples, and stay tuned, you'll enjoy it. So let me begin to give you the big picture of this first class. This first class we call function of, let us begin with function of single variable. What do we mean when we say function of single variable? Possibly that's the question that you have in your mind. So let us just go intellectually like this one. That what is function of single variable? Because we want you as engineering students to understand stuff and not to crave. What the meanings of the single variable? What the meanings of the functions of single variable? What is functions of single variable? What does it mean? You can pause the video and write on your own. What do you understand? What do you get as a mathematician? What does come in your mind? So we say that this is the one of the definitions. We say that is a function. This is the mathematical function. Is a function in which this is the function in which it's dependent. It's dependent. It's dependent variable. Okay, it's dependent variable, which is commonly that to say variable, that to say y in most cases, right? Depends on what? On single variable. Depends on single variable. Depends on single independent variable. Depends on single independent variable. So that's the answer. So it's a function in which it's independent. So this is its dependence. If you're watching from India, please tell me in the comment sections you're enjoying this stuff or these contents, from which institutions, from which regions, if you're enjoying Tanzania, from which city, if you're enjoying Nigeria, just tell me in the comment section from which continent, from which country, tell me in the comment section, because this is a generational braid of mine. So it's a function in which its dependent variable, let's say y, depends on a single variable, and commonly this single variable that we've been sung for long times is x. However, that it can be y, it can be n. So these are just, I'm giving you the overview. So what are the examples? So let me give you the examples, because you are familiar with this, but you didn't determine the functions of the single variables. So examples, the first example, for example, if you have f of x is equal to 5x. So this is the single variable function. Why? Because we have a dependent variable, which is y, is equal to 5x. X, it is independent variable, y, it is dependent variable. Right? And then we say that, again, you can have another function, right? So you can have maybe a variable, now it is t, but this is common also equal to y, that returns as y. But this now is equal to, let's say, 3t squared. We can also have another function that, possibly that we have f of x. This is equal to cos of x plus, let's say that x squared minus 4 sec of x. So this is another example of a function. Again, we can have another example of function of single variable, that maybe you can have y. This is equal to x squared minus 4x plus 3. Again, we can have another example of function of single variable, that you can say that y is equal to conj of x and then plus what? E power x and then minus what? Minus we said that e power x minus x squared, or minus, yes, so minus, let's say, ln of x. So all of these are examples of functions of single variable. Why do you call them functions of single variable? Because the independent variable on left hand side the dependent variable on left hand side depends on the one single independent variable. So for instance, for this one, the dependent variable is y, and the dependent variable is x. For this one, the dependent variable is y, and the independent variable is t. For this one, the dependent variable is y. The independent variable is x. However, that we have tricky functions. This is a algebraic or polynomial function. Also, this is a dependent variable. This is independence variable, right? Again, we have that. This is example 5. This is the dependent variable. It's dependent variable, which is y. Then x, it is what? Independent variable. This is a hyperbolic function, conj of x. This is exponential. We call it natural exponential function. So natural exponential function is e power x. And this is natural logarithmic function, ln of x. So we have been dealing to, when we say that we are dealing with calculus of single variable, right? So we've been differentiating these functions, we've been integrating these kinds of the functions, we've been dealing with solving or finding the volumes of maybe of the particular figure, finding the area of the sector, whatever. We've been dealing with this stuff, maybe simplifying this function, or maybe, for example, that we have some identities, trigonometric identities or hyperbolic identities. So we've been dealing with this single variable function. But today we have a good news, right? And the good news in your house is I want to teach you and introduce and build a strong foundation, because the house is always laid up on the foundations, right? So I want to build a strong foundation on functions of several variables. So stay tuned. So if you have any questions about single variable, functions of single variable, you can ask in the comment section, right? Okay, don't forget to subscribe, because we are going to have more than 500 lectures or videos in this platform. That's why that we are really insisting to you that if you feel from your heart you are receiving these contents free of charge, actually that you will be paying a lot of money to have these contents, right? But because the owner of the work has asked me to do this as a chieftain to the Tanzanians and even other worldwide students, you have to make sure that you will offer your free willing thanksgiving to God, not to Olenjola. I have nothing to give you, right? So this telephone number so that you support the running cost. So more lectures, almost about 500 of higher engineering scientific mathematics will be in air. So the present and future generations can take advantage of it. Okay, so now let us go to the number 2, functions of several, functions of several variables. Functions of several variables. Functions of several variables. And we have a fundamental question. This will be question number 2 for this lecture. What is? So now we want to answer the question, what is function of several variables? What is functions of several variables? So you're answering now. This was the homework 1, which I left for you, so you can check now whether you're right. So function of several variables. Function of several variables. Write in your mind. Functions of several variables, so you cannot forget. So function of several variables, we say that this is a function. In which it's dependent variable. So remember that we have lectures and solving tutorial questions. Its dependent variable, which is single, right? Its dependent variable depends on more than one. More than one independent variable. More than one independent variable. So function of several variables. Functions of several variables. So we say that this is the function in which its dependent variable depends on more than one independent variable. Right? So that's the meaning of this. So let me give you examples, however, that I will teach you soon about what are the examples, right? Examples. So the first example, let me start with simple. Y, so let's say that we have y is equal to x squared plus t. So this one it can express in terms of function that f of x, comma t. So this is the simplest example. So let's say that we have t cubic. So this is the simplest example. So these functions depends on the two variables, x and t. It means y dependent variable depends on x and t. So that's why I call it f of x, comma t. Let me give you a second example. Second example, we have f of x, comma y. This is equal to x squared plus what? Y squared. So in these situations where x and y are independent variables, maybe we can let these functions, let's say that f of x, comma y is equal to z. Right? So don't claim that always the dependent variable is y. In the context of the functions of several variables, even y can be independent variable. It's not common like in case of what function of single variable, right? So keep that in your mind. Do you understand what am I teaching you? Please tell me in the comment sections if you understand what am I teaching you. So this is the second example. Again, you can have a third example. I'm still beginning with simple examples. So let's say that I have FFW, but let me speak mathematical later on, so I'll come into the real life. A function which depends on x, y, is a, for example, volume of the box. And then I can have, let's say, x squared minus 4y squared plus, let's say that 1 over z. 1 over z. So this is a function of several variables. We have how many? This is dependent variable. Regardless that whether it is z or it's w, we can call w if you have x, y, z, so this you can call w. Okay, mathematics is a common later, but it depends on x, y, and z. So the function f of x, comma y, comma z depends on three variables, x, y, z. Right? So again, let me give you the first example. The first example, you can come back into the against at least that move from polynomial functions, so we can say that you can have x squared, a mixture of, and then you have cosine of y squared, right? And then you can have, let's say that cotangent of 40, cotangent of x, right? Tangent of x, maybe minus what? Minus y squared, right? Y squared, and then you have sec of what? Sec of x. So this the function depends on x, y, xy, one xy. Polynomial function, 3D function, hyperbolic function. Interesting. I know that you are very competent in this stuff. If you are not competent in this stuff, don't worry. I'm teaching mathematics from Form 1, Class 9. I'm teaching mathematics Class 9, Class 10, Class 11, Class 12, Class 13, Class 14, Ordinary Diploma first year, Ordinary Diploma second year, Ordinary Diploma third year, right? And also undergraduate first year and undergraduate second year. So don't worry about that. Don't get confused with this stuff. We'll enjoy them. Okay. So the fifth example now, let us go. So we can say that we can have f of x, comma y, comma z. This is equal to what? This is equal to x squared plus e power y. Then minus, let's say that we have ln of z, right? Ln of z. And then you have, let's say, logarithms of x equals y. And we have minus what? Minus common logarithm, so a common number, exponential, common logarithmic number, let's say 10 power z squared. So this is another function. A sixth example, also you can deal with real life variables now. Functions of the length, comma width, comma width, comma height. Okay? Or thickness, comma height. So you can say comma height. So this one you can say that it is L times width times height. Right? So this is, for example, volume of the box. But also you can have another function which depends on the radius and what? And height. For example, volume of what? So you can find volumes of what? I can say volume of the cylinder. So volumes of the cylinder, it is given as formula is pi r square h. Pi r square h, 2 pi r square h, if I'm not mistaken. 2 pi r square h, and the volumes of 40 of the cylinder. So it depends on radius and and height. So you have so many. So these are the real examples now. You can have maybe temperature. And temperature depends on the two parameters, x, y, z, and this is possibly latitude, longitude, time, and hence you can find that possibly the functions is maybe this is x squared, ln of y, then minus, let's say what, maybe minus e power z. So those are the examples of what functions of several. These are examples of functions of several variables. These are the examples of functions of several variables, more than one variable. None of the function from example 1 to this one that depending on only one variable. All of these functions depending more than one variable. Okay. So if you have any question, don't hesitate to ask in the comment section. Okay. So now you know the definition, you know what I mean. So the function of several variables for now. And keep this information for the rest of your life. And keep this information for the rest of your life. You need this. You remember me, right? In our engineering courses. So then we say that we can have classes or types, let's say, we can have that maybe classes of, because classes of 40 of classes of functions, classes of function of 40 of several variables, classes of functions of several variables, classes of functions of several variables. So we can classify these functions mainly into 3 classes. And it's very important because we'll be paying on focus on the first class and second class. Stay tuned. Do you enjoy the beauty of engineering mathematics? Tell me in the comment sections. Do you love it? Tell me in the comment section. So you say that in mathematics, whether engineering mathematics or pure mathematics, we say that there are three main classes of what? Of function of several variables. Okay, these classes are the first one, we call it 2 functions of 2 variables. Don't worry, we're gonna solve so many questions. Functions of 40 of 2 variables. Functions of 2 variables. Okay, and then we have the second ones. This is function of 3 variables. 3 variables. 3 variables. And then we have again the third one, functions of multivariable. Of n variables, multivariable. It's more than, right? Or functions of more than 3 variables. Okay, functions of more than 3, or we call it more than 3 variable. More than 3 variables, or we call it multivariable. Called it multivariable. Called it multivariables. Functions of more than 3 variables or multivariables. Functions of multivariables. So we have those 3 types of functions, right? Those 3 types of the functions of several variables, right? So let us break down. Okay, let us enjoy now the beauty of these 3 functions. The first one is called the first class. We call the functions of 2 variables. Functions of 2 variables. Functions of 2 variables. What is it? It's the fundamental question. What is function of 2 variables? Because I need you to understand, not only to solve stuff that you don't understand. So we say that it is a function. This is the function in which, right, in each dependent variable, which is always 1, a dependent variable, the function is only 1, depends on only 2 independent variables. 2 independent variables. So it's a function in which dependent variable depends on only two independent variables. So let me give you examples. So examples. The first example is this one. So this is the function in which this dependent variable depends on more than one. So this is the function in which this dependent variable, for example, let's say depends on only two variables, x and y. Right? So then the second example is a function that depends on x and y. This is equal to what? This is equal to, let's say that we have 3x squared minus 4y cubic, and then plus ln of x times y. So how many independent variables we have? Two, x, y. How many dependents is only one, f of x, y. So this is the dependent variable, right? And then the second example, we can have that, let's say, even we can name it, let's see, we have z depends on x and y. So you have x squared minus 4 sec of y plus, let's say that e power y, and then ln of x. So that's another example. First example, can have that, let's say that we have f what, as I say that for the real life examples, f of r comma h, okay, as the volumes of what? Volume of the cylinder, right? Volume of the cylinder. So it is 2 pi, or let's say that, yes, because if you say volume of the sphere, it is 4 over 3 pi r square h, something like that, pi r cubic, something. Don't remember them how. So f of r h, this is equal to pi r square h. Okay, because it depends at which type of the cylinder. So that's the example of functions of two variables. So you see that mean that this is volume, right? This is equal to volume. So the volumes of the cylinder depends on the radius, multiples of radius and height. Again, we can have another example. Okay, we can have another example. And this example means that this example, we say that, well, volume of sphere, or volume, let's say that yes, volumes of sphere. So volume of sphere is equal to 4 over 3 by r square sphere by r cubic sphere. So you have radius, yes, by r cubic. So this depends on the one variable, volume of a cone. Okay, so we have some, for instance, also you can have maybe temperature at any point on the S, depending on two parameters, latitude and longitude of that place. So Tx, y, possibly can find that in particular place, this is x squared, y squared minus x, y. So all of these are examples of what? Two variables. So examples of two variables. Examples of two variables. Okay, so it means that you find that the functions depends on depends on the only two. The functions depends on only two variables, right? So I want to give you some more examples of two variables, so that you can enjoy the beauty of engineering and scientific mathematics. Let me give you some real life examples. Example in real life, example of what? Of function of two variables in real life is this. We say that the temperature, let me call it the temperature T Okay, the temperature T at a point, the temperature T at a point on the surface, of the S, at any given time, can be a function. It depends on the T. Okay, depends on two parameters. Okay, depends on one, longitude. Is it longitude or latitude? Okay, latitude. Let's begins with latitude. Because latitude are horizontal lines, latitude, which you can call it, this is variable x, mean that the temperature on the surface of Earth, for instance, the day temperature in Tanzania. So you have to know the latitude where Tanzania is located and its longitude. So you can know the temperature at any time in Tanzania. So then we say that we have 1 and 2. Also this one depends on the longitude, longitude, which this longitude you can call it y, of the point. So this is the end of rotation. So this is the one of example of the functions of two variables. This is two variables in real life. So for instance, you'll be given a problem, so you are designing an engineering system which you want it to operate at every point of the S, and these your engineering systems can be affected by the variations of temperature. So you have to think mathematically how can your system possibly that we call it just how can your systems maintain its working temperature. So it means that possibly you can have maybe a temperature sensor and that temperature sensor, or maybe you can have maybe a way that you can have maybe the longitudes and latitudes from the GPS, okay? And then after you have those informations, you have established a certain function which these locations will have various temperatures, and your system maybe you can have a cooling system also, if it will be affected by overheating. And even also in case that it will be affected by the low temperature in some places or in some points of the Earth, then your systems should have a heating system, right? So then this one mathematically now we can write like this as mathematicians, that T, we can think that T means the functions of the two variables x and y. So T is the function, so suppose that T, this is the function functions depends on what? On two variables, longitude, latitude, and what? And longitude. So you say that this is the function which is t, x, comma, y. Right? So that's one of the examples. So you can say that this is the function that depends on, so it means temperature at any point of the S depends on x and the y. So it depends, what does it mean? So this is mathematical, but meaningful, temperature at any point on the S depends on the latitude and the longitude of that point at any time. So say that at any time. So also this one you can write as this is equal to the function of what? So you can write that, so you can write like this way, or you can write a little bit maybe as the equation. So this is the expression. Then you can write this one as the equation, that's the dependent variable t now. This depends on the two independent variable x, y. X represents what? Latitude. Y represents what? Longitude. And t is what? Dependent variable. So we say that this one, this is dependent variable. So this is dependent variable. And this is independent what? This is independent variables. Okay, independent variables. Right? So that's one of example. But a second example is volume of the circular cylinder. Say volume of the circular cylinder. You enjoy the beauty of mathematics? So we have an idea of function of two variables, but we have never discovered that the function of two variables. And in case that maybe if you do remember that how we've been dealing with parametric differentiations, for instance, it means that we've been keeping one variable constant and then differentiating the other one, right? So keeping one variable constant and then differentiating the other one. So the second example, so this is, let's say, this is example 60, example 7. So we say that in volume, I want to give you real life examples because I say the main objective of online undergraduate Polytechnic Institute of Tanzania is to train you or to mentor or to incubate or to teach you how you can use the classroom instructions, combine the knowledge of Word of God to solve real life problems. So you say that volume of what? Volume of the cone. So let's say volumes of the circular cylinder. So circular cylinder. So if you are finding the volumes of the circular cylinder, the volumes of circular cylinder depends on what? Depends on what? On the two parameters. Radius, which is r of what? And what? And the height. Height of what? Height, which is h. This is the not symbol is h of what? Of circular cylinder. So I remember that we met with this formula possibly during our primary education. And you know that. We used to say that volumes of the circular cylinder, this is given as pi r square h. So how we can write now in terms of the function of several variables? Pi is constant. So these volumes, which is dependent variable, depends on the radius and the height of the cylinder. And this is given as pi r square h. Right? So this is the functions of what? Of several variables. So possibly we can also write that this is ffr, h is equal to volumes are the functions of r and h, and this is equal to pi r square h. Beautiful. So I believe that at this moment you are competent enough and you know more. It means that you know in detail about about functions of the two variables. There are so many issues that will be dealing with domains, range. We'll be dealing with domain and range of the single variable or function of single variable. And here even also we can think about domain and range of of multi-variable, of function of several functions of the two variables. So I don't want to take you in depth. Today I want to build just the foundations and then we'll keep on discussing and learning this stuff. So, and also you have to keep to bear about the requirements, the course content, the course outlines. The second class, I say that function of three variables. Say functions of three variables. Say functions of three variables. So its definition is common. So this is question 3 for this lecture. What is functions of what? Of three. What is functions of three variables? What is function of three variables? Simply say that this is the function in which its dependent variable. Okay, its dependent variable depends. It's only one. Depends on what? On 3 independent variables. 3 independent variables. 3 independent variables. Right? Depends on the 3 independent variables. This is the definition. Function of 3 variables, which actually in undergraduate level we end on dealing with function of single variable, function of 2 variable, function of 3 variable. We are not allowed to go into the functions of multiple variable. And you know that if you relate with vector, according to what I've taught you in matrices, so function of single variable, that is equivalent to one-dimensional vector. Function of 2 variable, that is equivalent to a 32-dimensional vector. Function of 3 variable, that's equivalent to 3-dimensional vectors. And you know that we have 3-dimensional figures in our daily life. Our houses are 3-dimensionals. Our cars are 3-dimensional. Even the border of OLENJOLAI is 3-dimensional. You see, so even my hands, this is 3-dimensional. So we have so many structures which are 3-dimensional in life, and that's why that we are learning functions of 3 variables. Okay, so let me give you examples now. I give you some mathematical examples, and then we say that I will give you the real life examples. Let me start from the big picture, from your fundamental concept. So a function of 3 variable, we say that we have f of x, comma y, comma z. Right? So this one depends on a certain function, x squared plus ln of z plus e power 1. So that the function depends on the 3 variables. And then you have another function. You have, let's say, w. This w depends on what ln of x y. And then we say that we have x squared y, and then minus e power z. But the function of 3 variables. You can have against another function of 3 variable, which can be g of x, comma y, comma z. This is equal to it. This is equal to log e of z squared, then minus 4 ln of x, and then plus what? Possibly that we say that we have 3 power what? Power y. Function of 3 variables. So you have so many examples. The first example, we have also f of x, comma y, comma z. This is equal to what? This is equal to y squared. Y squared minus 4xy plus 3x ln of z. So you have so many examples. So many examples of function of 3 variable calculus. So now we are teaching you function of 3 variable calculus. Later on, I'm going to teach you a concept which is one of our concepts that we cover, partial derivative. You know what are we going to do? I'm going to teach you about how you can differentiate this function. Partial derivative. How can you differentiate a function where its dependent variable depends on more than one variable? And also I'll teach you how you can differentiate this function. It's very simple to differentiate. And later on, so you can learn even how we can do double interval, triple interval. We'll be learning in this same course. So stay tuned and expecting great things to come in your mind. Not in your hand, at your hand, in your mind. Okay, so against the real life examples, this is example number 5. We can think about volume of what? Of a box. Volume of a box, we say that depends on what? Depends on length of the side, which is our height of the box, which is called the h, and what? And width. Width of what? Which is the view of what? Of the box. Okay? So in this one, what do we say that? We say that the volume depends on what? Length, comma, height, comma, width. And this is equal to length times height times width. So you can write like that once, right? Volumes is equal to that once, right? Is equal to that. So it means that, or sometimes that you can say that, let's say V, this is equal to V, the functions depend, but in this case, we just mentioned that this dependent variable V depends on length, height, and what, and weight. We can also let mathematically that let L to be equal to X, let H to be equal to Y, let width to be equal to Z. So you can have that maybe volume, which the function depending on three variables X, Y, Z. This is equal to what? This is equal to X, Y times Y times Z. That's the real life example. But the sixth real life example, in the previous example, when I've been teaching about function of the two variables, you know what happens? When I was teaching you about that functions of the two variables, right? I gave you an example of if you want to determine the temperature at any point, it means that at any point on the S, or the temperature on the surface of the S, depends on the two parameters, latitude and the longitude. Latitude, latitudes are variable X and longitude are variable Y. But again, we say that at any given time. So it means that time is common. So now I want to just to teach you to think more than, means that to think differently now, means that to think greater is in this way. What if that you want to determine the temperature on the surface of the S at any time over any place, means that at any latitude, any longitude, at any time. Then you'll find that the temperature now as dependent variable will depend on the three parameters. First of all, the latitude, secondly, longitude, and the third independent variable is time. So that's the sixth example. So I say that temperature on the surface of the S temperature T, so I have a reference here, temperature T at any point temperature T at any point on the surface of the S. On the surface of the S depends on the latitude, which is X, longitude, I'm about to finish this session. Okay, longitude and the time. Longitude and time. So it depends on the latitude, longitude, and the time, which this time is T. So now this is the function. So it means that T, remember that T, this is dependent variable. What does it depend? It depends on the latitude, longitude. So latitude, longitude, and the time are what? Are independent variable. So for that case, we say that T depends on X, Y, Z. T. So T. So if you write at the function, this is expression, write at the function, T depends on what? On the T is a function of X, which is latitude, Y, which is representing longitude, T, which is representing what? Time. So this is the function of three variables. Okay. So those are the examples. So you have to think now, I want you to be aware that when we we've been speaking about functions of several variables, you have to know what should come in your mind. All right? Okay, that's very important point. Again, another point which is very important which I want to make is we say that we have again another the third class, which is we call it, or which I call it function of what? Of more than three variables. We have to think as mathematicians. Also, we have to think about this type of the function of more than three variables. What is it? Right? So what is it? So this is the question that we have. What is function of more than three variables? You can pause the video and try yourself to answer that question. Right? So you say that this is the function in which its dependent variable depends on more than three independent variables. So depends more than three independent variables. Examples. Of course, we learn mathematics by examples. You can have a function depends on the three variable f of x, y, z, t. Then here we have t squared minus ln of y plus e power z, and then we say that plus what? Plus log e of x. We also have another function f of x which depends on x, y, z, t, and hence we say that here we have also some other variables away from x, y, z, t, and possibly that may be a. This is equal to e or a plus x, y plus, let's say that t squared minus we say that logarithms or log of what? Log of, we have already presented this for variables. Okay, log of z. Okay, so this is the first example, this is the second example, and the third example, we also have that maybe we have f of x, y, z, t, w. This is equal to what? This is equal to 3 w minus 4 x, y, z, then plus what? Ln of what? Ln of t, then plus 4. So all of these are examples of function of more than three variables. We call them function of multivariable. So from function of two variable, function of three variable, function of more than three variable, all of these three classes of the function call them multivariable functions or functions of multivariable. So you say that means that you say that. So you say that function of multivariable consisting function of single variable function of two variable function of more than three variables. So that's the meaning of function of multivariables. 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 So these functions of more than three variables, so you say that the function of more than the functions of more than three variables can be presented in general form as R of n. So whereby R of n, this is possible that is the functions of n, where I have maybe x1, comma x2, comma x3, but these are lengths up to xn. Right? So that's R of n. So this is equal to the function of x1, comma x2, comma x3, comma xn. Means that dash 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 up to xn. So this is equal to Rn. So this is equal to functions of more than three variables. Okay. So I give you mathematical examples of functions of more than two variables. Right? So then now I want to take you into the next point. I want to give you a real life example. So this will be example 4. Example 4. So you say that suppose a certain company, certain banking company, let's say, company is making bread by mixing several ingredients ingredients. Suppose a certain baking company is making bread by mixing several ingredients. So that's what, so you see, for example, if you want to make possibly, for example, let us take this flag, the national flag of Tanzania. So you can say in terms of color. So how many colors does this flag contain? So 4 colors: green, yellow, black, and blue, right? So what happens? So it means that we can say that this flag, the flag is dependent variable. And then these 4 colors, these are independent variables. So it means that the flag of United Republic of Tanzania depends on the 4 variables. So similarly, you can find that we are consuming a lot of items in our bodies ourselves, which have been made by the several ingredients. So because it means that, for example, if you want to make a bread, the bread just maybe depends on the amount of the sugar, amount of the salt, amount of weight, amount of water that I'll be using, maybe amount. So you see that the rate depends more than one variable. Another example, we are drinking soda, for example, Coca-Cola or Pepsi. But you know that Pepsi, it comprises so many ingredients. So we as engineers, once we design a system maybe that for producing a soda, so we have to design a machine which we have to feed all of these ingredients, and then that machine possibly has the software that we can interface and provide the commands that make sure the amount of the sugar in each bottle should be in this amount. Make sure that the amounts of the gas in each bottle it should be this amount. Make sure the amounts of the color is this amount. Make sure the amount of the flavor is this amount. So you see, that's applications of function several variables. So with that, let us go to this example because I want to just excite you. Suppose that N represents what? Different ingredients that require different ingredients are required to make what? Was to make the bread. And then suppose CI, this is the cost. Is the cost per unit of the ingredient. So cost per unit ingredients. Okay? Then 3. This is CI. 3. Then we have XI. XI, suppose XI represent units of the I, units of the I's ingredient. Units of I ingredients are used. So then, how we can write the functions? For example, then the total cost of ingredients. So then the total cost maybe will be given this problem by the owner of these companies to calculate the total cost of the ingredients that will be used by the company. Of the ingredients is given as, so we can write a function of more than 3 variables. So we want you to think differently and think how you can take these informations to solve a real life problems, because that's the purpose of us to go to school. So suppose that the cost, we use the letter C, the capital letter C, represent the cost of ingredients. So the cost of ingredients for this case will be functions of XC1, which is what ingredients used, and then the second ingredients used, and then the third ingredients used, and then dash 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 to the nth ingredients that used, because we don't know. And this one is the cost will be what? It will be a product of amounts of the ingredients that been used times the cost of that unit of ingredients. So it will be here the cost of that ingredients, which is C1 times what? Times RXC1. Okay? So this is n different ingredients. So you have several. So this is the cost for one ingredient. Then once I have to add to the cost of the second ingredients. So second ingredients, unit of the second ingredients, this is the cost of the second ingredients. Then I add C3 and X3. Then I add dash 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 to the cost of the nth ingredient, units of the ingredients, and the X of n ingredients. So this is the function of 40. This is the function of more than 3 variables. Well, so this is the end of the session, end of lecture 2. I know that you've enjoyed it. You want me to continue. So if you want me to continue, don't hesitate yourself to join me in lecture 3, when now I'm going to teach you another concepts, right? So let me give you the homework. I'm still building the foundation. So this is the homework tool. So the homework is this. Okay, so then, so let me give you the general questions. What is the domain of multivariable? Variable. Okay, multivariable sort function. Multivariable function. So what is it? So then, that's the first two questions. Second question, how can you find the domain of function, FCT means function, of multivariable. Third question, mean that do question 1 to 2, means that do question 2, mean that question 3, what is range? Because we taught you range of function of multivariable. So challenge yourself, go and read, have this mindset before you learn lecture 4, so that your mind will be fresh. Okay, so this is question 4. Okay, so the first question again, how can you find range of multivariable or function of several variables? Okay, so this is the end of this session, right? So let me just leave you so that you can copy the homework. This is the end of lecture 3, lecture 2 of functions of several variables in the models of several variable calculus. I really thank God who have given me a gift of teaching, and I thank God who have prepared me effectively for this session, and I thank God who have been with me when I've been teaching you these concepts and build these new concepts in your mind. And I thank God also who have given you an opportunity to learn through online undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim. May God bless you abundantly, and I would like to invite you in lecture 3. Keep on praying for me so that I have to achieve what I have promised you, and I have to make sure that so many lectures and so many sessions of several variable calculus are in air for the present and future generation. And also I will keep on praying for you so that God will give you prosperity or prosper you in your academic life and also after your academic life.